Yo, what's up, geometry students? Let's go and get ready for this big quiz. Uh, Not going to explain a lot, mostly going to just make sure you understand. All these questions really are designed for you to make sure you set up the correct equation, solve the equation correctly, make sure you provide the answer that we're looking for, and that's it. So, the adjustable, adaptable math students, don't think you're doing the same thing for every single problem. Pictures help. Some of the questions we provide pictures, some of the questions you need to provide the picture yourself. So being ready for everything. Here we got A, B, and C are collinear. That'll be annoying. A, B, and C being collinear means they're on the same line. I might have to go somewhere else. Okay. Uh, I can see AB is X, BC is 3X minus 2, AC is 18. Well, it should make sense that AB plus BC is AC. So I'm going to set up that equation and solve that equation. Set up, solve the correct equation. I get X is 5, but I double check to make sure I have the correct answer. Like segment BC would be 13. Plugging in 5 in for 3x minus 2. Okay, P, Q, and R are collinear. I don't have a picture. I need to provide it. PQ is twice the size as QR. So PQR, 3 in a row. PQ is twice the size of QR. A lot of students read a question like this. They're not told what X's are or anything. So they just start guessing and checking. Don't do that. QR, we don't know. PQ is twice that. So assign a variable to QR. QR is X. PQ is 2X. The total length we were told is 10. So we should do 2X plus X, which is 3X, equals 10. 2X plus X equals 10. We divide by 3, and you get X equals 10 thirds. This is a decimal. It's not a nice decimal. It's a 0.333 or 0.666. So just leave it like this. But they're asking you what is the length of PQ. You would double 10 thirds. Doubling 10 thirds, if you remember multiplying fractions, just multiply across, you get 20 thirds. PQ is 20 thirds. I'd leave it like that. Cool. One segment plus another segment equals the entire segment. Makes sense? But then all of a sudden they throw something like this at you, like a midpoint. K is the midpoint. Midpoint, middle, middle. Very important to understand. If you know the middle, you know we have half on one side and half of the other side, or we have two equal segments. The left side, the right side equal each other. If you think we're doing the same thing every single time, you're probably adding these equations together. Don't do that, because these two segments are equal to each other. 5x minus 2 equals 8x minus 14. We then solve. I would subtract 5x. I would add 14. I would get 12 equals 3x. I divide by 3. I get x equals 4. That's not the answer. I'm asked for the length of JL. So I'm going to have to plug in 4 into both if you want to confirm that you're doing things correctly. If you plug in 4, you get 18 here. If you plug in 4, you get 32 minus 14, which is 18 there. Okay, that checks out. X equals 4 works. Left is 18, right is 18. The entire segment must be 36. Okay. Question number 4 is the hardest question for students. They see this and they say, okay, 2x plus 5 must equal 5x minus 1, because we're talking about bisecting, which means that's the midpoint. But you would be completely wrong if you set up that equation. 2x plus 5 does not equal 5x minus 1. 2x plus 5 is just half of my segment AD. So what we can either do is double this. We could say if that's 2x plus 5, this has to be 2x plus 5. We can double it to get 4x plus 10. We could actually take 5x minus 1 and divide that by 2 to get 2.5x minus a half and set that equal to 2x plus 5. I wouldn't want to do that, though, because I'd have decimals. So I would just get 4x plus 10 by doubling 2x plus 5 equals 5x minus 1. Solving this, I get x equals 11. The length of AD, it should all work out. If you plug in x, everything should work out. We should get 54. We should get 54 many different ways. Whether you plug it into AS and double it, you get 22 plus 5, which is 27. Double this 54, plugged it into 5x minus 1. Everything works out. This is another hard question because you have to draw the picture. Z is the midpoint of EY. Make sure Z is in the middle of EY. You were told EY is 20. That's the entire segment being 20. You're told EZ is 5x. Z is the midpoint. Figure it out. I gave you a hint. X is not 4. Well, you're thinking, oh, this is 5x. This is only part of my segment. CY has to be 5x as well. Giving you 10x has to equal 20. X is 2. You could have said since EY is 20, EZ must be 10. EZ is half of EY. Next, S is bisecting UA. Man, who made this question? USA are collinear. US is 8x minus 2. SA is 10x minus 8. You're not given UA. You're given US and SA. What do you do? Oh, you're not sure. Should you add them together? Well, remember what it means to bisect. Bisect means we cut in half. 2 equal parts. Our equations equal each other. We do need to find UA. It should all work out. If I plugged in 3 here and plug in 3 here, we should get the same value, right? We are bisecting. We have equal parts. So I get 22 if I plug into 8x minus 2. I get 22 if I plug into 10x minus 8. 22, 22, 44. D is in the interior of angle ABC. Angle ABD is 5 times the size of angle DBC. Angle ABC is 50. What is the size of DBC? Pictures given to you just to help you guys for the next question. This is what it means to be in the interior. It's just like inside your angle. You can create the ray BD, that point D being in the interior. It's helping you saying, hey, this angle ABD is 5 times the size of angle DBC because they said that DBC is X. Since the entire angle is 50 degrees, what we could do is set up an equation. 5x plus x has to equal 50. 6x is 50. That doesn't work out nicely. Divide by 2, I get 3x equals 25. I get x is 25 thirds. Okay, not a great number, but that's the correct answer. So probably tricking you to think that x is 10. X is not 10 in that situation. Okay, now you draw the picture. W is the interior of POA. POA is a 90-degree angle. You don't have to worry about making it to scale, but if you want to kind of read ahead, you can see that there is a larger angle WOA. It's 8 times the size of POW. What is the size of angle WO? Well, WO is 8 times the size of POW. POW, I'm going to label as X. WO is 8X. Add them up. You should get 90 degrees. Which is not the size of angle WO. WO is going to be 80 degrees. Cool. Word bisecting shows up again. We have another situation where we are bisecting or cutting in half equally. We have the entire angle bed. We have half of the angle bet. Here's an example that I'm going to show you like 2 different ways. Option 1 versus an option 2. Option 1, which is what most students in my class do, is they say if bet is 2x plus 5, TED has to be 2x plus 5. And then they're like, okay, bet plus TED is 4x plus 10. That has to equal bed, which is 8x plus 4, giving me x is 3 halves. Divide both sides by 2, you get 3 equals 2x. X equals 1.5. Cool. Bed is going to be 1.5 times 2, which is 3. 3 plus 5 is 8. So bed is 8. Sorry, bet is no. Bed is going to be 16. Bed being the entire angle. Option 2, what is 1/2 of bed? A half of bed is 4x plus 2. You could say 4x plus 2 has to equal 2x plus 5. And that is another way to get 2x equals 3, x equals 3 halves. And then find angle bed by plugging in 3 halves. Now, let's just remember how to plug in 3 halves. 2 times 3 halves, you can multiply across and say it's 6 halves. You could cancel the 2's to just say that it's 3. So 2 times 3 halves, you can think of it as 2 times 1.5, or just like 2 times 3 over 2 is 3. Plus 5 is 8, double that. Number 10. Another bisecting. See if you can set it up. We got map. That's being bisected by AD. We got MAD. We got DAP. Well, since this cuts it in half equally, MAD's got to equal DAP. What's MAP? It's double DAP, double MAD. It's MAD plus DAP. DAP is 13 degrees. MAD is 13 degrees. Doubling that is 26 degrees. Number 11. M bisects kid. Figure it out. Be careful though, guys. Make sure your letters are correct. Make sure you understand you're not given kid. You're given Kim and mid. You have half and you have the other half. We are bisecting. We are cutting things in half. This is not a double one set equal to the other. This is 8x equals 3x plus 40. We get 5x equals 40. We get x equals 8. Since it's bisecting, we can see that each of these angles must be 64 degrees. You can double check, plugging in 8 into both. They should be equal. 64 doubled is 128. So that's angle kid. Complementary angles. What does complementary mean? Make sure you read carefully. Make sure you understand. There's that hint. Bisecting, big hint. Complementary, big hint. Complementary angles add up to equal 90 degrees, right? RHT is 7 times the size of B. I mean, it is kind of confusing because they're two different angles in two different locations. They're not really using any of the same side lengths. So we're talking about just one angle over here and another angle over here. RHT is 7 times BOX. So RHT is 7x, BOX is just x. Adding them together, we should get 90 degrees. I get 8x is 90. I'm going to divide everything by 2. I get 4x equals 45. I'm going to get x equals 45 fourths. I can't divide by 2. X is 45 fourths. Box is 45 fourths. RHT is 7 times 45 fourths. I wouldn't want you to do the math on this. So just like leave it as 45 fourths or 45 fourths times 7. Cool. 13 is very similar. We have a picture though. We can see the right angle symbol. So these two angles have to be added up to equal 90. This works out better. We should get x equals, finish it. X equals 5. Number 14 is really designed so you know how to set up the problem number 15. So we got 14, they give you the picture. You got to be able to do 15 after like seeing what 14 is. So it says angle ABC is 10 degrees less than 9 times its supplement. What's the measure of angle ABC? So we start by saying this angle is x, this angle is 9x minus 10. But the two have to add up to be what? 180, because they're on a straight line. It's easy to show supplementary angles by just drawing a straight line and then kind of going from there. So you should know it's very similar to the complementary setup. Add the two angles together, they should equal 180 degrees. Same side, combine the x's. X is 19. We have to do a little bit of math here. 171 minus 10 is 161. Oh, I don't know why I did that. Why did I just do that math? Like, think about it. We know that angle X is 19 degrees. We could have just subtracted 19 from 180. Don't take X multiply by 9 and subtract 10. If you did everything correctly, take 180, subtract 19, 161. That's got to be the angle. All right, now you guys try the next one, but you got to figure out the picture. We're talking about supplement, so we're talking about supplementary angles. Might as well break out a straight line. Don't worry about if it's to scale. We have CDE, which could be one of the angles on your straight line. We have two supplementary angles. I'm going to label one as X, and I'm going to label CDE as 2x plus 30. 30 degrees more than 2 times the measure of its supplement x. That's confusing. That's why we gave you 14 to help you out. 2x plus 30 plus x needs to equal 180. That's probably the most confusing question we've seen so far, but you better believe you're going to see it on your quiz come next class. Get x is 50. So CDE is 130. Cool. Then we go to the most recent lessons, where we see parallel lines, lots of mirror images, lots of angles that are equal to each other. Since we're lines, we see lots of supplementary angles. And using that fact, all of a sudden we see that the angles in a triangle add up to equal 180, because you can kind of see the connection between the straight lines in 180 degrees and the triangle with the 180 degrees if you have parallel lines. So don't worry about the terminology for right now. Like, yes, vertical angles are equal to each other. Corresponding angles equal each other. Alternate exterior angles equal each other. Alternate interior angles equal each other. Supplementary angles have to add up to 180. And boom, you have the other ones. 125s and 55s airwear. This is my favorite new problem. I hadn't seen this problem in the past. I love this problem. It's really like the proof of the triangle whose angles add up to 180 degrees. Use vertical angles, use corresponding angles to your advantage, and take it from there. Use the fact that some of your angles are on straight lines. Like, I'm going to go down to this 110, and I'm immediately going to know what the angles like adjacent to it are going to be. And I've just like filled out that bottom left corner. Now this 45 is tricky. We know the vertical angle is going to be 45 degrees. Cool. Take the picture, move it down, follow this other diagonal line, and you can see this bottom right corner angle is 45. Since that's 45, all of a sudden you realize that this must be 135. Cool. You got two angles out of three angles in a triangle. You add them up and there's 115, which means this must be 65 in here. I'll do this one in blue. If this is 65 and this is 45, you'll find all the other angles that you've already found will fall into place. You on 18? 18? All right, cool. All right, well, think about the situations. The angles are either equal to each other or they're supplementary to each other. So you look at this situation, and I'm like, are those two angles equal to each other or are they supplementary to each other? And that's it. Now, if you wanted help, you could start kind of writing what the vertical angles are, and you could really see, yeah, they're not in a corresponding place. Remember, we like to say, take one of the intersections that creates the four angles, copy and paste it over the other intersection. If they lie on top of each other, they are corresponding with each other. If they don't lie on top of each other, they're probably supplementary to each other. So this is one of the examples when they're supplementary. You add them up, set them equal to 180. We get 10x plus 60 equals 180. 10x equals 120. X equals 12. We want to find all the angles, so all the angles are going to be here. 12 times 6 is 72 plus 50. 72 plus 50 is 122. So this one's 122. There's 122 over there, 122 over there, 122 over here. And then the other angle must be supplementary to it. You don't have to do the math. You know that it's got to be 58. You could double check, plug in 12, multiply it by 4, and you get 48. And then you add 10, you get 58. So there's the other angles, 58, 58, 58. Same thing for 19. But you can kind of see that if you know your vertical angles are equal, we have what is possibly like corresponding angles that are equal to each other. These are actually alternate exterior angles. Alternate exterior angles are equal to each other. You can work your way to show that they're corresponding with the vertical pair. So these are equal to each other. You might want to do the same thing you do every single time, but don't do it. I get x equals 5. Find all the angles. Great. So let's label everything here. 5 times 5 is 25 plus 40. We have a 65. We have 65, 65, 65, 65. All of these are 65. And that means the supplementary angle is going to be 150. Then the most recent lesson, the last lesson, quadrilaterals. You cut it in half, you got two triangles. One of the triangles angles add up to 180. The other triangles angles add up to equal 180. That means all of the angles in a quadrilateral is just the same as two 180s or 360. We add up these four angles. We know it has to equal 360. Four, 5, 6, 7, 8, 9, 10. We got 36. We got double 36, which is 72. We got to add another 36, and we got 108. We're going to add another 36. We got 144. Yo, do that again. Do that entire review again. But don't look at this video at all. Maybe do the questions in a random order versus in order. Don't get them wrong. Anything you get wrong, do again until you can't get them wrong. Okay? Let's crush this quiz. Peace.